Welcome back, my dear students. In previous classes, we were discussing about compound stresses or complex stresses, right? Compound or complex stresses are just will recap a few things. Okay, compound and complex stresses means you will be having one pointer. That point can be written as like a plane, and there some stresses will be acting, and those stresses you know already. This is sigma x, this is sigma x, this is sigma y, this is sigma y, and it also subjected to some shear stress. And that shear stress we will call it as a tau xy or simply tau. Okay, this is a point where these all stresses are acting, therefore this is called as compound stress. Compound stress. And this is also called as complex stress. Complex stress. And there will be some plane of interest. This we can call it as a A and B as a plane of interest. On this plane of interest there will be two type of stress generates, that is a sigma theta, that is a normal to the plane of interest, and another one is tau theta, that is parallel to the plane of interest. And anywhere on this, that formulas you already know, sigma theta equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. This you know. The same way this already we derived. You can go back to the previous lectures and see the derivation. Sigma tau theta is sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. This also we derived. And after that there will be one plane, that one, I don't know the orientation, just there will be one plane out of these many planes. On that plane we will have a maximum normal stress. Maximum normal stress that can be written as sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau xy square. And there will be another plane here on this, these many planes are there, out of those one another plane is there. There we can have a minimum normal stress. That minimum normal stress is nothing but plus or minus. This minus I am using it for minimum and plus I am using it for maximum. This already derived and many problems are also solved. It's not a new thing. Okay. Then after that there will be another two planes. On that one shear will be maximum shear stress, maximum and minimum, that is equal to plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy square. Okay, and the orientation of principal plane we derived that equation also, that is a tan 2 theta p1 equal to 2 tau xy divided by sigma x minus sigma y. This is a major principal plane, and a minor principal plane will be theta p2 equal to theta p1 plus 90 degree, and maximum shear plane will be theta p1 plus 45 degree, and theta s2, that is your minimum shear plane, will be theta s2 equal to theta p2 plus 45 degree. These many things we covered. Derivations are also done and problems also done, and some understandings also we covered in previous lectures. Now we are entering into the same concept, same chapter, but the second heading that is called as Mohr's circle. That is called as Mohr's circle. Mohr's circle. Mohr is a scientist. This Mohr means this is the name of the scientist. That Mohr is there. He invented something, some technique to find out the sigma theta, tau theta, sigma 1, sigma 2, tau 1, tau 2, theta p1, theta p2, theta s1, theta s2. These are all there, and some understanding of this compound stresses and or complex stresses, but not by using these analytical methods. These analytical methods, by you will substitute something into in these equations and you will get the answer. But Mohr circle method is not like that. Mohr circle method is all about graphical representation of, once again, graphical representation of compound stresses. Okay, that we are studying here. Okay. First I will explain how Mohr got this conclusion that compound stresses can also be expressed in graphical method. है ना? There will be some history behind that, or how he might thought, how he might think that this compound stress, these all equations can put in a graph and we can understand that. है ना? That reason behind that is, I will explain that mathematically, that expression, or otherwise how he arrived that graphical method. You know, this is an element, this is sigma x, this is sigma x, and this is the normal stress again, sigma y, and this is also normal stress, sigma y, and this is tau xy. To compensate this, there will be another tau xy. Now these two are rotating in clockwise direction. To oppose that and make it equilibrium, we want tau yx. For equilibrium, tau yx. But mathematically we know that tau xy equal to tau yx. That simply I can write it as a tau, just a tau. You know? And all other conventions, whatever that we made in previous class derivations, they are same. For example, sigma x is greater than sigma y always. Sigma x, when it is tension, it is called as positive, it is taken as positive. Sigma y, when it is tension, it is taken as positive. Then tau xy or tau, for this sign convention I told you that right top corner positive. See here, right top corner, if these two arrows are there, then that is positive. If they come here left top corner, then they will be negative. But this convention we are not using it here. We are using it like clockwise shear positive, anti-clockwise shear negative. Clockwise shear, sir, how come shear can be clockwise? See here, one force act like this, another force act like this, then these two force together make a clockwise direction. Therefore this is called as clockwise shear. Even this force acts like this force act like this, then these two combinations also makes clockwise. Therefore these two are clockwise shears and considered as positive. And here anti-clockwise shear means one force act like this, another force act like this, these two causes a shear, and the combination of these two results in what? Anti-clockwise. The same way I can have another force like this, another force like this, these two forces makes shear again, then these two will cause a anti-clockwise direction. Therefore these two sign conventions I consider as a anti-clockwise shear, therefore negative shear. Come back to our diagram. Here this force and this force, these two are together, they are making clockwise, therefore this is positive, and this force and this force are making together, they are making anti-clockwise shear, therefore they are negative. Okay, na? This understanding you should know. And after that, going back to the analytical method, if I consider one plane of interest, let us consider this is a plane of interest making an angle theta with respect to vertical. If this is the case, then there will be two type of stresses induced. One is normal stress sigma theta, and another one is tau theta, that is the tangential stress on AB. Then analytical method, you already know the equation that sigma theta equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Okay, this is one equation. Another equation, tau theta equation, is sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. Right? Two equation we have. Now look at here. Now these all whatever I wrote here in red color, this black color, this is all predetermined, means we already know about them. That is nothing new in this one. But new thing comes here, that what Mohr thought about these all things. You know, that here Mohr says that this you call it as equation number 1, This you call it as equation number 2. On this equation you rearrange it. Sigma theta minus, you take this entire term left side, sigma x minus sigma y by 2, then equal to sigma x minus sigma y by 2 cos 2 theta, as it is this is, plus tau sin 2 theta. Okay, I will use tau only, tau xy it irritates, therefore I will directly use a tau only, right? This you call it as a third equation. Then after that you come here, this is already, it is keep it like that only, do not disturb this one. Then here we'll call this as a second equation and this is a third equation, because in notes it is like this, that's why. Okay. This is a second equation and third equation. Now what I do, I will square both and add. Okay, then if I square this, what happens? Sigma theta minus sigma x minus sigma y by 2 whole square plus tau theta square. See, this also you need to square and add, this also you need to square and add. This side, left side I squared and added, that equal to right side is now sigma x plus sigma x minus sigma y by 2 cos 2 theta plus tau sin 2 theta whole square plus sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta whole square. This one I need to rearrange. This one what I need to do, I need to rearrange. Then the left side, whatever that is there, that I will keep it as it is. Sigma theta minus sigma x plus sigma y by 2 whole square and their square. Keep it as it is. Plus tau theta square, keep it as it is. Then so here these things I wrote in the next slide, and after that, now this is square, this is a plus b, therefore a plus b whole square is a square plus b square plus 2ab, right? Then here, look at here, this entire term is there, no? This entire term I will call it as a cos theta, okay na? For your simplification. No, don't worry, I will take it, not make too much complicated. When I make things easier, that becomes complicated for freshers. If you are very child in mathematics, that becomes complicated. Let me go to the complicated way so that it becomes easier for you. This is a and this is b. A square b square plus 2ab, right? Now what is a? Sigma x minus sigma y by 2 cos 2 theta is a, correct? This is a square plus b square. B is what? Tau sin 2 theta, tau sin 2 theta square, a square plus b square plus 2ab, 2a sigma x minus sigma y by 2 cos 2 theta, a, b is tau sin 2 theta, okay na? A square plus b square plus 2ab. Then what is this? This one I want. This side I want. This side is what? A square plus b square minus 2ab. Okay. A square sigma x minus sigma y by 2 cos square theta, cos 2 theta whole square plus b square tau, it is not cos, it is sin now. This time it is sin. This is sin. Tau cos 2 theta whole square minus 2 times sigma x minus sigma y by 2 sine 2 theta into 2 cos 2 theta. Okay, in this equation if you see, then sigma x plus sigma y cos 2 theta, sigma x minus sigma x minus sigma y by 2 cos 2 theta, sigma x minus sigma y by 2 cos 2 theta, 2 sin 2 theta, 2 sin 2 theta. Therefore this and this cancels. Correct? Now here this I can write. How I can write? The left part is sigma x minus sigma y by 2 cos square theta plus 2 square sin square theta. Correct? That equal to sigma x minus sigma y by 2 whole square cos square 2 theta plus 2 square sin square 2 theta. Then left is sigma x minus sigma y by 2 whole square sin square theta plus sigma x minus sigma y by 2 whole square sin square 2 theta minus 9 plus 2 square cos square 2 theta. Now if I take this sigma x minus sigma y by 2 whole square common, then inside will be cos square theta, this sin square plus sin square theta, 2 theta, sin square 2 theta. That plus 2 square if I take common, then this is a sin square 2 theta plus this is a cos square 2 theta. Okay na? Here sin square 2 theta cos square 2 theta is trigonometrically 1 and this is also 1. Therefore sigma x minus sigma y by 2 whole square plus 2 square is the answer. Then what is the total end result? Sigma theta minus sigma x plus sigma y by 2 whole square plus 2 square 2 theta square is equal to sigma x minus sigma y by 2 whole square plus 2 square. Okay na? This much we got. This is one bracket. Okay, after doing this, Mohr excited, he become somewhat he said, eureka, I got something. By seeing this he was excited and he become very happy and he went to his teacher. I think he went and he showed to his teacher that, sir, I got this one, see here, I got something very wonderful, see, this equation is very wonderful, this equation gives me a lot of pleasure. He said like that. Why he said like this? By seeing this equation, can you judge? Can you think what is there in this equation in that way? You are not more, no? That's why you are not able to see that very exciting thing in this equation. That exciting thing in this equation is this sigma theta, he considered it as a x, then minus, he keep it as a minus, then this entire term he called it as a, then it looked like a square, x minus a whole square. Then here he looked this one as a 2 theta as a y and nothing is there here, therefore he can write it as a 0 square, no? X minus a whole square plus 2 theta minus 0 whole square look like same equal to, or otherwise you do one thing, this is y square only you consider, x minus a whole square plus y square equal to, then this entire term you consider it as a r square, then it look like x minus a whole square plus y square equal to r square. Again he altered this one like x minus a whole square plus y minus 0 whole square equal to r square. After doing this, after showing this one, then he got again the happy vibes, saying that, wow, what a nice equation it is. What is there in this equation? Can you judge? This is equation of circle. Equation of circle. Then what after equation of circle, we'll see in the next